Hello everybody, how are you? Today we'll solve a new exam, talk about statics, model last year, 2022, session 1. Question number 1 here. In the opposite figure, A, B, C, and D are 4 collinear points, A, B, C, D, where AC equal CD equal DB. The two forces 10 and 10 Newton form a couple and equivalent to the couple formed from two forces 40 and 40 Newton. If cosine theta equals 3 over 5, then we want to find the relation between theta and phi. Okay. Look at the opposite figure here. We have two couple here, 10 and 10, and the distance between them, we can find perpendicular line segment between 10 and 10 here to find momentum 1. Okay, we have here 10, it's force 10 and it's force 10 direction here, inverse to our. Then we can find momentum. It will be theta, and this length will be what? Will be 3x, because we divided it 3 part equal, let each part equal 3. Then this perpendicular line segment here, it will be 3x sine theta, 3x sine theta. Then momentum 1 by couple 10 and 10, it will be each one of them multiplication by height, which perpendicular, multiplication by 3x sine theta, and we know momentum 1 will be equal momentum 2. They give us this information because the force is 10 and 10 and the force is 40 40 and equivalent are equivalent, then m1 equal m2. Then you can find m2, it's m1. Okay, and what about m2? We can drawing this again. Okay, to clear 40 and 40. Okay, 40 here, it's 40 and it's 40 force is couple was parallel, and we want to find height between them. Height between them, we have here alpha and this part x. Look at here, this part x. So this perpendicular will be x sine alpha. Then momentum 2 will be each one of them 40 and here 40 multiplication by height x sine alpha, and we know momentum 1 equal momentum 2, then 3 times 10 equal 30 sine theta will be equal 40. We have here x, okay, and here x, we can cancel x by x. Okay, never mind. 40 x sine alpha, we can cancel x by x, and the result will be 30 sine theta will be 40 sine alpha. Then we can cancel 0 by 0 here, then 3 sine theta will be 4 sine alpha. You want to find relation between sine theta or sine theta and alpha. He give us information in the example here. He tell us cosine theta equals 3 over 5. Cosine theta equals 3 over 5. Then we can write sine theta equal 4 over 5. Put here sine theta equal 4 over 5. Then 3 multiplication by 4 over 5, it will be equal 4 sine alpha. We can cancel 4 by 4. Then 3 over 5 equal sine alpha, and we know sine theta equal 4 over 5. Sine theta equal 4 over 5 and sine alpha equal 3 over 5. What about alpha and theta? And we know cosine theta equals 3 over 5. Look at here, cosine theta equal sine alpha equals 3 over 5. It's meaning what? Theta and alpha will be complementary angles. Sum of them equal 90 degrees. Then theta plus alpha will be equal 90. Understood? If you draw this triangle here and this theta and this alpha, look at here, sine theta equal 4 over 5 and sine alpha will be equal 3 over 5. Again, if we draw a triangle here, then sine theta will be 4 over 5 and cosine sine theta equal 4 over 5 and cosine theta equals 3 over 5 and sine alpha equals 3 over 5 and cosine alpha equal 4 over 5. Then cosine theta equals sine alpha when theta plus alpha equal 90 degrees. Shows letter D about this example. Okay. Question number 2. AB is a rod of null weight raised on smooth support at C. The rod is equilibrium horizontal if a weight of kilogram is suspended at the end A. Here. At weight 144 kilogram at B. Is suspended for the other end B. As figure 1, and rod is equilibrium if a weight 36 kilogram. Here 36 kilogram is suspended at the end A weight of kilogram weight is suspended from the other end of BF. Find the ratio between AC and CB. We can find the momentum of C here equal momentum of first equal C here, because the distance equality here and R1, we don't know R1 and R2, so we can cancel R1 and R2 here by find momentum about C here. Momentum C we can write here will be equal 0 because it tells us equilibrium. Okay. Then we can find the force here, multiplication CA or AC, it will be equal 144 multiplication by BC. Multiplication by BC. And next figure here, we have F multiplication BC, force multiplication BC here, equal 36 times CA. 36 times CA. Okay, this force times distance, because we have the momentum of this point C equals 0. You can divide it relation number 1 and relation number 2 here. Force cancelled by force, then AC over BC will be equal 144 over 36, and CA cross CA equals CA power 2, and BC times BC equal BC power 2, and then we can find square root about left hand side, right hand side. Then AC over BC equal 12 over 6, it will be 2 over 1, then the ratio will be 2 to 1. Choose letter A about this example. Question 3. A body of mass 5.6 kg is placed on horizontal row plane. Okay, row plane here. This body here. We have a body. Okay. Here, and we have the weight here in the down. It was row and we have here R, and the weight here about mass 5.6 kilogram. We know T here equal T, and static friction between the body and the plane 3/5. Then we have here M multiplication by N. Mu give us mu here in the example what? 3/5 R. If the body moving here, R multiplication by mu will be equal T, and R equal 5.6. And we know the put here about the weight. The body is tied to the end of light in selected string passes through small spoly fixed at each of the plane, and the other end of the string is tied supported vertically. Skull plane is mass 1.1 kilogram. This weight 1.1 kilogram to down. Okay, then the weight can be put in skull pan to make the body about to move. Okay, so the moving down, to move this body here, direction will be going down. Then we can write T here equal 1.1. Okay, 1.1 equal T, and we have here T equal, the result will be what here? 5 divided by 5 equal 1, and 6 divided by 5 equal 1, and the remainder what? 5 divided by 5 equal 1, or use calculator to find the result, and then subtract the result by 1. The result will be 3.36. Subtract 1.1, it will be 2.26 kilogram weight. Again, we put here the body weight of it equal M kilogram, and we have here R and the weight 5.6. T equal T here to this pole. Understood? This pole here, T equal T, and T equal M plus 1.1, and here 3/5 R multiplication by R equal T. We can call it Rn as you like. Then 2 T here equal R multiplication 3/5, and we know here T equal 1.1 plus M. We can write 1.1 plus M here, and moving 1.1 to right hand side inverse sign, the result will be 2.26. Understood? So in this example we have a body here. We want to find the weight of anything put here to get, or can be put the skull to make the body about to move. It will be what? It will be 2.26 kilogram weight. We must choose letter D. It's clear for you? We have this relation number 1, T equal 1.1 plus M, and the relation number 2, 3/5 multiplication R equal T here, and we can equality between them because T equal T to the body. Then 1.1 M equals 3/5 multiplication 5.6, then M equal 2.26 kilogram weight. Understood? Choose letter D. Question 4. In the opposite figure, R is the result of two parallel forces. Resultant or total about the force 1 or 3F, force 1 or force 2. Their magnitude are 3F and F Newton. If AC equals 7 cm, we want to find the length about EP. We know our result about 3F and F equal 2F. You can find momentum to this point P to find the result, or you can find momentum to the point C as you like. Okay, it's force F, and we have here 3F, and this R, and we can find momentum to C equals 0 to cancel R here, and this length 7 centimeter, and it will be X. Then 3F multiplication by 7 will be F multiplication by X plus 7. 3F times 7 equal 21F equal XF plus 7F. We can cancel F by F by F. Then X will be what? We have here 3 times 7 equal 21, and F times X, then X plus 7, X 21 will be X plus 7, then 7 will be equal 14 centimeter. So the length will be equal 14. AB will be 14 centimeter. Choose letter B. Question 5. The coupler parallel forces F1, F2, F3 at the point A, B, C respectively. This is the algebraic measure of the moment of the resultant of these forces about the original point equal space. Moment unit. Look at this word parallel. Forces parallel, it's meaning L over negative 2 here equal K over 4 equal L plus 1 over 5. We can find the ratio between them. Okay, the ratio between here, look at here, we have F1 equal L and K, and F2 equal negative 2 and 4. F2 equal to F3, and the ratio between L over negative 2, it will be K over 4. It will be L plus 1 over what? L plus 1 here divided, we can find the ratio between L plus 1 and negative 2, it will be equal 5 over 4. Then we can find here L plus 1 equal negative 2 times 5 equal negative 10 over 4. 4 times L equal 4L plus 4 equal negative 10. Then 4L will be equal negative 14. Then L will be negative 3.5. We have here result of L. Then you can find K about this friction here. Negative 3.5 over negative 2 equal K over 4. You can cancel negative by negative, and then K will be 4 multiplication 3.5 over 2. Then K will be 2 times 3.5 equals 7. Then K will be equal 7, and L will be negative 3.5. And here L plus 1, L negative 3.5 plus 1 equal 2.5. Negative here, negative 2.5. Okay, I will complete the result here now. F1 act on F1 was negative 3.5 and 7, act on the point A, negative 1 and 2, and F2 act on the point B, and the order of it negative 2 and 3, and F3 negative 2.5 and 5 act on point C, 0 and 4. We can find momentum equal what? About choose the point O. He give us point, original point, so we want to find about O. It will be here R1. It will be this point, the end subtract by the beginning, it will be negative 1 and 2. It's R1 multiplication across F1 negative 3.5 and 7, and this point R2 here negative 2 and 3 cross negative 2 and 4, and R3 multiplication force 3 cross 0 and 4 cross negative 2.5 and 5. Okay, and then you can find the result. Extremes subtract by means, and here extremes subtract by means, extremes subtract by means, and find the result. The result will be equal what? Using thinking about the result here, the result will be equal 8. Choose the letter C. Question 6. In the opposite figure, if the force of magnitude 602 here acts in the straight line whose slope equal 1, passing through point 0 and 1, then the algebraic measure of the moment of the force about the point -3 and to point B. Okay. Now, we know the force here act on straight line here. This straight line here passing through the point A, and this force was 602. Act on the point here 0 and 1. We can convert force here from the result or magnitude here to vector. How we can write vector F? By write the force in the magnitude multiplication by vector D over union of vector D. It will be 602. He gave us this information. The slope was 1. Slope is 1, it's meaning this straight line, we can write equation about this straight line R equal 0 and 1 plus k constant multiplication by 1 and 1 is the equation about straight line. And we know if acts on this straight line, then the vector here u or d will be 1 and 1. Write 1 here and 1 over root 2. It's the square root about first and second plus يعني 1 bar 2 plus 1 bar 2. It will be 1 over 2. Okay, again d here 1 and 1 over what? Over root 2. Why? Because force acts on the straight line, and this line was 2.0 and 1, the slope equal 1. The slope equal 1 is meaning the vector about straight line L, it will be 1 and 1. Then we can cancel root 2 by root 2. Then the force will be 6 times 1 and 6 times 1. This will be 6 and 6. We have now the force F. Then the algebraic measure of the moment of the force about the point B equal what? We can find momentum about point B. Look at point A, and we have another point B in this plane. Is the order of it equal -3 and to it B. So we can find BA, vector BA cross the force F. Okay, we can write here PA, it will be A subtract by B. B was, he give us B equal -3 and 2. The difference between them, 0 minus 0 equal 3, 0 minus 3 equal 3. And 1 minus 2 equal -1 cross about force F here 6 and 6. We can find the result by product extremes, subtract by product by means. 3 times 6 equal 18, subtract by -1 times 6 equal -6 plus 6 equal 24. The result will be 24. Okay, right, 24. It's the algebraic measure of the moment of the force. The result will be 24, letter A. Question 7. A, B, C, D are rhombus. Here, two forces of magnitude 20 and 20 kilogram weight for a couple, also two other forces of magnitude F and F kilogram weight from another couple. If the system is equilibrium, then F equal space. It's meaning what? M1 plus M2 equals 0 because the system was equilibrium. Magnitude 1 or moment 1 plus moment 2 equal 0. Momentum 1 and momentum 2 equal 0. We have a rhombus here, and we have here 20 and 20 couple forces here. We can draw perpendicular side here, and this angle 60 perpendicular, it will be 30, and the opposite here I will write L here, the side, all side equal lengths. Then the result will be L sine this side length sine 60. Okay, so momentum 1 will be equal negative 20 because it's crossing with the hour, multiplication by length multiplication by sine 60. The result will be negative 20 multiplication by L multiplication sine 60 equal root 3 over 2. 2 and cancel 20 divided by 2 equal 10. The result will be negative 10 L root 3. It's momentum 1. And we want to find force equal. We have F1 and F2 here. And we will be draw here. It will be equal L because we have equilateral triangle. All sides will be equal in length here. So the momentum 2 by the force F and F will be each one of them multiplication the perpendicular side length between them. It will be L. Then M1 plus M2 equals 0, or M1 inverse about this. We can convert or comparing between them to find the result or equality using the result here. Momentum 1 plus momentum 2 equals 0. Okay, then we can write here M1 and M2. We will add them about momentum 1 momentum 2, then negative 10 L root 3 plus F multiplication by L equals 0. We cancel L by L, then the force will be equal negative 10. It's moving here, it will be 10 root 3. The force here will be 10 root 3 kilogram weight. 10 root 3, choose letter C. Question 8. ABCD is a wire with uniform thickness and density is bent at B, C, and D. Okay. Where measure B equal measure C equal measure D equal 90 degree. And CB equal DC equal D equal half of AB. Okay. It's equal half of this. Okay. Then the distance of the center of gravity of the wire from each AB and BC. Look at here, B here, common between AB and BC respectively. Okay, then we must find the distance about center of gravity to B. Okay, I will draw it here with you. We have here this part and perpendicular here and here perpendicular to know the steps. Okay, it will be E and D and C and B and have A here to 10 centimeter and it 10 centimeter and it 10 centimeter. We can write the center here about this. It will be 0 and here come up 0 and 10, and the center about this line here wire it will be what 5 and 0, and here this will be, it will be what 10 here, this line segment about this, it was E, and the distance will be here 0 to 5 center, or here the center here. Okay, the center about AB 0 and 10 right here. Okay, and here it will be 10 and up 5, and center here 10 plus 5 equal 15 here, moving 10 and 5 here equal 15 here, and going up 10 it will be 15 and 10. Understood? Okay, then we can find X about gravity here, or using drawing first table to know your work here. We have A and B and center about this point here, about this line segment EP. It will be the weight here, what, it's twice all of them, it will be 2m, and here will be m and m and m. Okay, I will write 2m and the center about it 2m here 0 and 10, it's x and y, and m here about BC the order 5 and 0, and m here about DC and the order 10 and 5, and DE here with m 15 and 10. Okay, and then you can find x about gravity, the center about gravity. It will be what? 0 times 2m, 5 times m, it will be 5m plus 10m plus 15m over sum of them, 2 plus 1, 3, 4, 5. We can find 15 plus 15 equals 30, 30 divided by 5 equals 10x, and we cancel m by all them. And y equal 10 times 0 equal 0, 0 times m 0, 5m plus 10m over 2 plus 1, 3, 4, 5. The result will be 15 divided by what we have here, 5m and 10m, and 2m times 10 equal 20m. It will be 35 over 5, it will be equal 7. The center will be 6, 7. This is the center. Okay, the center will be what? Look at here, center will be 6 and 7, going 6 and up 7, it will be B, and center here. So he asked about AB, where AB, AB, the distance, look at his word, AB to BC, BC, the distance about AB equals 6, AB distance respectively about AB and BC. The order here 6 and 7, going 6 and up 7. AB, it will be 6 units, about 6 centimeter, and BC 7 centimeter. The result will be 6 centimeter and 7 centimeter. Choose letter B. Okay, understood? Question 9. In the opposite figure, ABC is a fine line of nullable weight in the form a right angle triangle at B. Mass is magnitude 12, 13, 5 gram. Okay, 12, 13 at A and B and C. Okay, respectively. Okay, we can drawing it here. This triangle here, A, B, C, and the weight at 12 at A and 13 at P, 13 here, and it's C 5 gram. It's all weight here. Okay, okay. The triangle subtended freely from B. Okay, so we must draw here coordinate about this point here to find what the tangent of the angle inclination of BC to vertical equilibrium position. Okay, equilibrium position here, where we want to find the center about the gravity here. So we can write the order. This length here was 12 centimeter and it was 5 centimeter, and we can find the center about it here. Okay, we can using two methods. First method here, we have 13 here and 5, and this weight here was 12. Okay, okay, right, the center about this weight here between B and C, or can write the order, about this. It will be 12 and 0, and here equals 0 and 0, and here will be 0 and 5, and right the weight 1 13 here, coordinate about 13 0 and 0. Okay, and coordinate about 5 here equal 12 and 0, coordinate about 12 here, 0 and 5. It's x and y. Then you can find x by gravity here. 13 times 0 equals 0. 5 times 12 equals 60. 12 times 0 equals 0 over 13 plus 5 plus 12. 15 plus 5, 20. 60 divided by 30. 25 plus 5 equals 30. The result will be equal to, and y about g equal 0 and 0 and 5 times 12. 5 times 12 equals 60 over sum of them equals 30. The result will be 2. We want to find the tangent about this point here, 2 and 2, going to and up to this angle here will be 45. Then the tangent of angle, it will be tan 45 equal 1. The result will be 1 because the tangent meaning tan 45. Tan 45 equal 1. The result will be letter A. Next question here, number 10. In the opposite figure, if a force magnitude 10 root 3 unit acts at point A and makes the positive coordinate axis angle theta x, theta y, theta z, or theta x equals theta y, theta z equal 0. Where theta is the acute angle, then the moment vector of f equal space. Okay, look at here about this figure here. Okay, look at here. We have the force a point A here, if acts in the point A, and they give us the magnitude force equal 10 root 3 force acts on the point, and makes the positive coordinate axis equality. It's meaning what? We know the force will be the value or magnitude of force multiplication by vector u over magnitude about vector u. He give us this angle here, theta x equals theta y equals theta z. It's meaning what? We know cosine theta x plus cosine theta y power 2 plus cosine theta z power 2 equal 1. He tell us the three equality angles. Then 3 cosine theta all power 2 equal 1. Then cosine theta all power 2 equal 1 over 3. Then cosine theta will be 1 over root 3. Okay, then we can write the result here, 10 root 3 multiplication by 1 over root 3 and 1 over root 3 and 1 over root 3, because it will be cosine theta x, cosine theta y, cosine theta z, and 1 over root 3. We can find the force will be what? Multiplication 10, it will be 10 and 10 and in the force. Why? Because he tell us in the example the forces acts at the point A and makes with the positive coordinate axis theta coordinate equality. Right? Yes, it tell us equality. Then force equal magnitude of the force multiplication by vector u over vector u in the magnitude of the norm about vector u. The result will be here cosine. We can cancel this, right? Cosine theta x, cosine theta y, cosine theta z. They are equality, and we know the relation between them. Sum of them equal 1. Then cosine each angle of them equal 1 over root 3. We can write it here. We used here vector f equal magnitude about the force multiplication by cosine theta x, cosine theta y, cosine theta z. Okay, we use this rule to find what? To find the force. It's the first step. Second step here, we want to find what? The momentum vector f about the point B. Look at the point B here, where B here. It's order about B 3 and 0 and 0, and we have point A here. We can find the distance between B and A and then cross the vector F to find the momentum about B equal BA cross the force F. Then momentum about P, it will be BA cross the force F. we can write here I and j and k, BA equal A subtract by P. We know BA, it will A vector A subtract vector B. Vector here we can find A, the order of A equal what? Look at here, negative 3, negative 3, 3, negative 4, sorry, negative 4 and 3 and 12. Negative 4 and 3 and 12, subtract vector B. Vector B here equal 3, 4 and 0 and 0. It's 4, okay? It's 4. 4 and 0 and 0. The difference between them, negative 4 minus 4 equal negative 8, 3 minus 0 equals 3, 12 minus 0 equal 12. Okay, it's PA. Write it here, negative 8 and 3 and 12, and first we get it here 10 and 10 and 10. You can find the result by using calculator or find the result. It will be what? Negative 90 and 200 and negative 110. It's the result. Choose letter A. Letter A. Look at question 11. In the opposite figure, AB is a uniform rod of weight 10 kilogram, weight attached at iron fixed in the ground at A here, and tied from B by light. Select a group bathed on smooth poly and carries weight W from the other end here. The rod equilibrate in position makes the angle 30 degree to the horizontal A here, angle 30 degree, and the rope makes angle 30 degree with the vertex P here. This is the magnitude of the reaction at the high equal space. You want to find what? You want to find the magnitude of reaction type. Look at here, we have here poly, and the weight here down was W. The weight will be W here. Okay, and we have T here, and this tie to straight line here. This straight line making angle 30 degree, and we have point P here, and this angle equals 30, and we know T here. We can factorize T here, T cosine 30 here, and here will be T sine 30, and we have the weight here. He give us the weight 10 kilogram in the median, and reaction, we don't know the reaction, so factorize it here, y and x reaction. I factorize it reaction to x or y. Okay, this point A and here P. We know T equal weight here, and we can write left hand side equal right hand side and up equal down, because he give us this word in the example, this word where equilibrate, the rope equilibrate in position. Okay, so we can write here y plus T equal 10 plus this, and y plus 3. T can cancel by weight here, we can cancel them. Then y plus T cosine theta, okay, up here equal down, y plus T cosine 30, y plus T cosine 30 equal down here 10. Then y plus T cosine 30, this angle 30, cosine 30 equal root 3 over 2 equal 10. It's the first relation. Okay, y plus root 3 over 2 multiplication by t equal 10, and x will be equal t times sine theta. The right hand side equal left hand side, so t here equal t sine 30 equal x here equal t sine 30, then x will be half t. Okay, we have x and y, and we can find r by square root about x power 2 plus y power 2, but we don't know t, so we must find the momentum of any point. We can find momentum about the point A. Momentum A will be equal 0. We can cancel y and x and write here 10 multiplication by the length here was L cosine 30. Write the weight here 10 multiplication by L cosine 30. It's moving inverse to the hour, and this here t cosine 30 going by hour will be negative. Cosine 30 equal root 3 over 2, so it will be root 3 over 2t, root 3 over 2t multiplication by what? The distance here, well, 2l cosine 30, because it's adjacent. Okay, multiplication by 2l cosine 30, and this force t sine theta moving inverse, it will be positive. T sine 30 multiplication by this height equal 2l sine 30, because it's L and L, 2L multiplication by 2L sine 30. Sine 30 equal half, right? Half here, half, it was sine 30. Okay, we can simplify it, cancel L, the result will be equal 0, cancel L by L by L, and we have here cosine 30 equal root 3 over 2, and cosine 30 root 3 over 2, and then complete with me, it will be 5 root 3, and here cancel this number, the result will be 3 over 2 L, we cancel L, okay, plus t. We have here, first we have here t, this force root 3 over 2 t, we have t here, okay, multiplication 2l multiplication root 3 over 2, and sine 30 equal half, half divided by 2, and here t and half of t, we can write here half of t, it will be equal 0. Then negative 3 over 2 t plus half of t equal what? Equal negative 2. We can complete here, it will be 5 root 3 subtract t equals 0, then t will be 5 root 3. We have t here, and you can find y, put t here, and find x, because the relation between y and x here, put t equal 5 root 3 here to find what, and x will be half of t, the result will be 2.5 root 3, it's x, and y equal 10 subtract by root 3 over 2 by multiplication by t, it will be 5 root 3. Root 3 times root 3 equals 3. 3 divided by 2 times 5. 15 divided by 2. 7.5. 10 minus 7.5. Then y will be 2.5. We have x and y. Then you can find r. R equals square root about x power 2 plus y power 2. Then r will be square root about the first 5.2 power 2. 2.5 power 2 plus 2.5 root 3 all power 2, and then we can find r. R will be equal 5. Then r will be equal 5. The magnitude of reaction at the hang equal 5 kilogram weight. Choose letter B. Question 12. In the opposite figure, ABC triangle, M is intersection of the point of its medians. A force F magnitude 5 root 41 Newton acts in direction CM. Okay, we first here can find the order about median M. We have here triangle here. Point about A, it will be 6 and 0 and 0. And it was 3, so B will be 0 and 3 and 0. And we have C here. It will be order 0 and up 9. Then M intersection about 3 point here, the median. X plus x plus x divided by 3, it will be equal 2. And y divided by 3, x plus x plus x divided by 3 equal 2. 3 divided by 3 equal 1, 9 divided by 3 equal 3. It's M. So we can find what? We want to find MC direction. To find what? He tell us the vector of magnitude acts in direction CM. Okay, direction CM. Okay, so the force we can convert it, right? The magnitude 5 multiplication root 1, and CM he tell us about magnitude about CM. Then the force F equal 5 multiplication by 41 multiplication by CM, it's meaning M subtract by C. The M was 2 and 1 and 3. 2 minus 0 equal 2. 1 minus 0 equal 1. 3 minus 9 equal negative 6. Square root about 4 plus 1 plus 36. 5 multiplication root 41 multiplication by, it will be equal 41 here, and write 2 and 1 and negative 6, cancel this, and force will be 5 times 2 equal 10, and 5 times 1 equal 5, and 5 times negative 6 equal negative 30. We have the force here. Then momentum about point O, it will be O about B or OC as you like. See, very easy. Okay, OC cross the force F. We want to find the momentum about the original point. O will be MO, see, meaning OC or OM as you like, because the vector F acts on CM direction. Okay. Okay, we can write here I and J and K. OC, see, meaning C subtract by 0, it will be 0, 0, 9, and F will be 10 and 5 and negative 30. We can find the result. The result will be letter P, negative 45 and 90 and 0. Choose letter B about this example. Question 13. A body of weight 20 kilogram weight is placed on a rope laying inclined to the horizontal with an angle of measure 30 degrees and tied from a point it by a light elastic string passes over a smooth poly at each of the plane and weight suspended on other end of the straight scale plane of weight half kilogram weight. If the coefficient of static friction between them, the plane 1 and root and 2 over root 3, then the weight that should be put in the skull plane to prevent the body from oscillating. Okay, he asked about what's the weight. If we put it here, it will be don't going down. Okay, it will be not going down. So we will have here the weight was 20, and we have here angle 30 degree and angle 30 degree, and the weight here equal be what? the angle here equal 20 sine 30 equal 10, and here 20 cosine 30 equal 10 root 3. Okay, understood this? We have here r, and we have mu r because it's true, and the weight here will be right weight, and we have here t and here t. T equal weight and r equal 10 root 3, and we have 10 equal mu r plus t, mu r plus t, and we know t equal weight, t equal weight here, and he tell us the weight here half kilogram. Its weight half kilogram plus this here, we can find the all weight and subtract half by it, because this weight about this thing is half kilogram weight. Okay, if you find the all weight here, you can find the mass of thing here inside this pot. Okay, then we can write here 10 equal mu, give us mu equal 1 over 2 root 3 multiplication by r, 10 multiplication by root 3 plus weight. We can cancel root 3 by root 3, then 10 will be equal 5 plus weight, then weight, total weight equal 5 kilogram weight. Then the body will be what? We know the total here was 5, and 5 equal the weight of the thing here put in the skull pane to prevent the body. We can cancel half from 5 weight, the result will be 4.5. Understood? Because all the weight is 5 kilogram weight, and the weight of the thing here will be half. He give us the string of skull pane, this skull pane here, weight of it equal half kilogram, and we get the all weight here will be 5 kilogram weight. Then you must difference between 5 and half, the result will be 4.5. Then the 4.5 the weight should be put in the skull pane to prevent the body from sliding. Is kilogram weight will be what? Will be 4.5, 4.5. Choose letter D. Next question here. A body of weight 40 root 3 kilogram weight is placed on the row plane inclined to the horizontal by angle whose tangent 3 over 4. A force of magnitude 22 root 6 kilogram weight making an angle of measure 45 degree with the plane upwards acts on the body. If the body is put to move downwards, okay, move downwards. Look at here, this body and the force here. We can factorize the force. The force here 22 root 6. We can write 22 root 6 is angle 45. Cosine 45 equal 1 over root 2, and 22 root 6 multiplication by 1 over root 2. It's cosine about or sine 45. 22 root 6 multiplication by 1 over root 2. And we have r here, and the weight was 40 root 3. This angle theta and theta. 40 root 3 cosine theta. He give us 10 theta equal 3 over 4. It will be 5. Then 40 root 3 cosine theta, cosine it will be 4 over 5. Multiplication 4 over 5. 40 root 3 multiplication 4 over 5. And here 40 root 3 multiplication sine theta. Sine theta equals 3 over 5. 3 over 5. Okay, and it was 0. So we have here m multiplication n. We have here m multiplication by n because 0, and it will be moved downwards. Okay, move downwards. We can complete it. Find mn plus 22 root 6 equal 40 root 3 multiplication 3 over 5. And we have here r. Write r or n as you like. Write here r or n. Write n because I write it here n. Okay, as you like. So you can write the equation n plus 22 root 6 multiplication 1 over root 2 equal 40 times root 3 times 4 over 40 root 3 times 4 over 5. And then you can find n by using calculator, programmable calc. And then n will be 1 over 5. We have here n. The result will be letter C. Question 15 is the opposite figure. If the force F acts at the point B, its magnitude is 60 Newton about F, then the algebra measure of the moment force about the point C equals space Newton centimeter. Okay, we have the force here and direction about the force going here, angle 150. We can write angle here 30, supplementary angle here, and the force was 60 Newton. We can write 60 here, sine 30, and here 60 cosine 30 to the point C. This distance 30 root 3, as distance here 8 centimeter. We can find momentum about point C by first force. It will be negative 60 sine 30. It will be root 3 over 2 multiplication space here about line segment. He give us about this distance here. Look at here, this distance here, it will be 80 centimeter. We know sine 30 equal half. Okay, understood or not? Okay, I will write it again. Look at here, this force, it will be negative 60 sine 30 multiplication by the distance here 80, and this force going inverse to the clock, it will be 60 cosine 30 multiplication by the distance here will be 30 root 3. The result will be here sine 30 half of 8 equal 40, negative 60 times 40 plus 60 multiplication cosine 30, it will be root 3 over 2 multiplication by 30 root 3. Okay, root 3 times root 3 equal 3, and 3 times 30 equal 90, and 60 divided by 2 equal 30, plus negative 6 times 40, right, double 0, and 6 times 4 equal 24. Negative here, it will be negative 2400 plus 2500. We can add them to find the result. The direction here was negative only, and it's only negative, it's the same, so the result will be negative 5100 Newton centimeter. Choose letter B. Question 16. AB is a non-uniform ladder of length 4 meter and weight 200 Newton. Rests with its end A on a row horizontal ground. The coefficient of static friction between them 3/5 and its end be resist against smooth vertical wall if the leader about to slide when inclined to horizontal by an angle measure 45 degrees in the point action is with as a distance equal space meter from A. Okay, look at here, we have the leader here and through it will going here, so we will have here multiplication by R going the inverse, and it will be going down here, it will be R2, and we have here R1 reaction here, and this reaction, and we have here the weight here. Okay, we can write left hand side equal right hand side and up equal down, then R2 will be equal multiplication by R1. Mu give us mu here equal 3/5 multiplication by R1 give us in this example R1 or not give us R1. We can find R1 in this example. Okay, give the weight here 200, this weight 200. Okay, and we can find momentum about any point such that point where, look at here, 200 Newton, it's most vertical, 45 angle here, this angle 45 degree. Okay, we can find momentum. We can cancel this point here was A, momentum about A will be equal 0. Then 200 will be moving about the positive direction. Multiplication by this length, I will put it length here will be x, and x cosine 45 equal 1/√2, and R2 moving here, negative R2 moving here, and we know R2 equal mu R1. Okay, R2 multiplication by the length here, it will be like this, it was 45, it will be x here, and the length was 120, this length was 4 meter, so this length will be 4 sine 4, this length will be 4 sine 45. Sine 45 equal 1/√2, it will be equal 0. Okay, and we can find x, but we have here R1 will be equal 200, and then R2 will be mu multiplication R1, 3/5 multiplication by R1 will be 200. 200 divided by 5 equal 40. 4 times 3 equal 120. Okay, it's R2 and R1. Then the result here will be what? Will be 200/√2 x will be equal R2 multiplication by 4. R2 equal what? Equal 120. Cancel this, right? 120 multiplication by 4 multiplication 1/√2. Cancel √2 with √2 here, and x will be 120 times 4/200. We can cancel 0 by 0. 12 divided by 2 equals 6. 6 times 4 equal 24/10 equal 2.4 meter. 2.4 meter. Choose letter C. Again, explain it again. Okay, you know R2 equal mu R1 and R1 equal 200. You want to find the distance here, x equal what? You want the point of action of its weight. Its weight here is the distance is made from A. You want to ask it about this distance. So we can write R2 equal mu R1 and R1 equal 200, and we can find momentum about A equals 0. The result here tell me 2.4. X here equal 2.4. Okay. ABCD is isosceles triangle. The force is measured in Newton. Shown in the figure are represented by sides of the trapezium completely. If the system equivalent couple, then the norm each moment equals space Newton. Okay, we have here trapezium here, isosceles trapezium. Two sides equal a length here. Here, and we have here F2 and F3 and F1 and 20, and we have it's 20 centimeter, and it was 40 power here. The force, we know momentum equal twice about area multiplication by m. Will be 2 multiplication by area about trapezium, half times base times height here, and height space was 18, and 42 minus 18 divided by 2 equal what? 18, and 18, and 42 minus 18 equal 24. 24 divided by 2 equal 12. It will be 12 this part, and this part 12. And we have here 20 centimeters, so we can write the height from face upwards. 20 power 2 subtract 12 power 2 and find the root equal 16. So the base here, greatest base equal 18, the smallest here, and greatest equal 42 over 2 multiplication by height 60, multiplication by m, the inverse about, or m inverse to ratio between the force and the height. The force here 40 over the height here 20. We can cancel 2 by 2, and 42 plus 18, 8 plus 2 equal 10, 0 and carry 1, 2 plus 4 equals 6, and cancel here 2 times the number here, 2 times 16 times, it will be 32 times 60, right, 0. 2 times 6 equal 12, 2 and carry 1, 3 times 6 18 plus 1 equal 19. The result will be 1920. A body of weight 5 Newton is placed on a raw horizontal plane. Horizontal force acts on it, make it about to move if the measure of limiting friction angle 60 degrees in the magnitude of the resultant friction. I want to find the result about the force of the total. Okay, we have here body, and here's the force, and the weight was 5 Newton, and we have here R or N as you like. We know F equal what? Mu multiplication by N, because the force here, then the total power here will be what? Will be, look at here, angle 60 degree. Okay, measure of limiting friction 60 degree. We can find mu, it will be tan 60 degree equal root 3. Understood? Okay, we know the rule, n dash, it will be square root about n power 2 plus mu n all power 2, because n equal 5, and the force here equal multiplication by n. F equal multiplication by n, and he asked about what? The magnitude of the result reaction here, result reaction here, or n dash. It will be equal mn power 2 and n power 2, and we can find the square root about them because we have right angle triangle here. Understood? F equal mu multiplication by n, and we know n equal 5. Right here, n dash, it will be n power 2, n equal 5, 5 power 2 equal 25, and mu multiplication by n, mu equal root 3, multiplication by n equal 5, all power 2. The result will be, by using calculator, 100, it will be equal 10. The result will equal 10. Understood? Because he won't find the magnitude of the resolution reaction. It's meaning n dash here about this triangle, mu n here, this mu n, this force here because it's rho, and the force going here F equal mu multiplication by n. Question 19 is the opposite figure. Mn equal Nb equal 20 centimeter and Mn equals 60, and the system of forces which measured by Newton acts as shown in the figure equivalent couple the algebraic measure of the resolution resulting couple 3600. Okay, we know m1 plus m2 equal 3600. Give us this information because we have to couple here. First couple here 40 root 3 and here 40 root 3. Okay, we want to find the distance between them. It's the distance between them here. Look at this line segment. The length about it equal what? 60 plus 20 plus 20 equal 80. This line segment equal 80 centimeter, and we have angle here equal what? 30. It's equal 30 here. It will be 30 degree. Okay, and this length perpendicular, it's adjacent about 30, and this angle equals 60. You can write 80 multiplication by sine 60 or cosine 30. Then we can find m1, write 40 root 3, it's moving inverse about clock, multiplication by 80 times sine 60. This line segment 80 or 100 again, 60 and 20 and 20 again. Yes, it will be 100. All line segment 100. Why? Because this part equal, look at here, this part 20 centimeter and this part 20 centimeter, and this part mn equals 60 plus 20 equal 100. And the length will be 100. Multiplication by sine 60 equal root 3 over 2. Then momentum 1 equal, it will be 50. 50 times 40, right, double 0, and 5 times 4 equal 20. 2000 and root 3 times root 3 equal 3. The result will be 6000. Momentum 1. Okay, it's momentum 1. And what about momentum 2? About force F and F. Okay, F and F. Look at here. This force F and this force F. We want to find the perpendicular between them in this line segment here. If we draw here line and this line, it will be what? Look at here. This line was mn. From mn was 60. He give us this line segment from m to n equal 80 centimeter, and this angle equal what? This angle, if we draw here, it will be 30. Vertical opposite angle, it will be equal 30. Then this line will be what? Will be 40, because it's opposite. It's a line opposite about 30. It must be half of hypotenuse. Then magnitude 2 will be going here with the clock negative. The force was F, multiplication by 40, and then we know m1 plus m2 equals 0. Momentum 1 here equals 6000. With the difference between them, it will be 5 minus 3 equal 2 divided by 30. Then F will be 24 divided by 3 equal 8, and write 0. Then the force equal 80. Write 80. Choose letter C. Question 20. AB is a non-uniform ladder of length 25 meter and width W kilogram weight acts at the point C, where EC equal 10 meter. Look at here. We have this point A and the weight here. It was 10 meter about point C, and complete with me here. The leader rests its end A smooth horizontal ground and its other B against smooth vertical wall. The leader is kept in equilibrium horizontal light wrap. One of its ends is attached at midpoint. Okay, attached in midpoint here, it's meaning its equality. 10 here, subtract by 12.5 because the length 25, it will be 20.5, it will be 2.5 here, 5 meter, and this point C. Okay, and it was T, and this point B. We have here reaction 2 and here reaction 1. Okay, we want to find tension in the rope. Tension in the rope, T, want to find T. Okay, we know R1 will be equal weight, up equal down, and right equal left. The left here equal T. R2 will be equal T. Then we can find magnitude about point B will be equal 0. Cancel R2. Then T will be rounding here or moving by clock will be negative T multiplication by height here. Height here is what? This angle equals this angle here. Okay, I will put angle here equals theta. To find this length, we must write 12.5 what theta about sine theta. Okay. Okay. Look at here about the weight here. I want to find the length about weight about B, this angle. We can find common angle between theta and it will be equal theta, corresponding angle here. Okay, but we don't know the length here. Okay, we can write hypotenuse. Okay, never mind. Again, we can write T here multiplication by this side opposite theta and hypotenuse 12.5. We can write 12.5 multiplication by sine theta, and write weight negative weight multiplication by the hypotenuse here will be equal 15, and angle here theta sine theta. Okay, weight multiplication 15 sine theta, and we can cancel R1. Then we have two force R2 and W. We have R1 here, yes, R1 here, because R1 we know the distance between it and the point B here. It's moving here, perpendicular about this, it will be here. This is a base. This is a base. We know all side lengths here 25, and this angle was theta. And then you can write R1 plus R1 multiplied theta and negative 15 tan theta divided tan theta equal 15. The result will be 2 cotangent theta subtract 15 multiplication by W by divided by sine theta, then T equal 10 over 12.5 tan theta multiplication by W here, and the result will be 10 over 4 over 5 W tan theta. Shows that RD.